Hello, class. Let's tackle this problem on number properties. The question gives us a condition. A is a number less than 0, which means A is negative. We need to figure out which of the three expressions listed, I, 2, and 3, must also be negative. The key word here is must. This means the expression has to be negative for every single possible negative value of a. Our strategy will be to test each expression one by one. Okay, let's start with expression y, which is -1 divided by a cubed. To determine the sign of this whole fraction, we first need to figure out the sign of the denominator, a cubed. We know a is negative. When you cube a negative number, you're multiplying a negative by a negative, which is positive, and then multiplying that positive result by another negative. A positive times a negative is negative. So a cubed will always be negative. As you can see from the example, if a is -2, a cubed is -8. So looking at our fraction for expression y, we have a negative numerator, which is -1, and we just determined that the denominator, a cubed, is also negative. Based on the rules of division, a negative number divided by another negative number always results in a positive number. This means expression y is always positive, so it definitely cannot be our answer. All right, let's move on to expression 2, a plus 10. Remember, we need to check if this must be negative for any negative, a. A good way to test a must-be statement is to look for a counterexample. Let's pick a simple negative number for a, like -2. If we substitute this into the expression, we get -2 plus 10, which equals 8. Since 8 is a positive number, we have found a case where expression 2 is not negative. Therefore, it must be negative, and we can eliminate it. Now for our last one, expression 3, which is 2 times a to the power of -1. The first thing that should catch your eye is the negative exponent. Let's simplify that. Remember the rule for negative exponents. A variable to a negative power is the same as 1 over that variable to the positive power. So a to the power of -1 is just 1 over a. This means our expression 2 times a to the -1 simplifies to 2 over a. Now let's analyze this simplified fraction, 2 over a. We have a positive numerator, 2, and the problem tells us the denominator a is negative. A positive number divided by a negative number will always result in a negative number, no matter what specific negative value a has. This means expression 3 must always be negative. So to wrap it all up, expression I is always positive. Expression 2 can be positive. Only expression 3 is guaranteed to be negative for every possible negative value of a. Looking at our choices, this means 3 only is the correct statement, which corresponds to option C. And there we have it. The final answer is C. This problem was a great exercise in applying the rules of number properties. By systematically analyzing each case and remembering the rules for signs and exponents, we arrived at the correct solution. Great job, everyone!